Yeah, hey everyone, I'm Scroggs. You've seen me a bit this weekend. If you don't know who I am, here is my slide of things I've been asked to plug this year. This is maybe your first Chocolates plug from the stage. I am one of the people involved in Chocolates magazine, if you've not had that yet. Or you have any friends that would like one, we have a ton at the back you can take away with you. I've been doing the Save the Prime project with Alian and Katie recently, so that is online now. I do the Finite Group thing with Peter, Katie, and Alian. If you go to there, you can join our Patreon for free, or you can sign up to join our live streams. And I do various other things, like I do an advent calendar of puzzles every year on my website there, which is coming up in just under a month's time, and hopefully some of you will join in with. But today, I'm going to talk to you about an interesting data thing I've been looking at in the last couple of years. To start this off, I'd like you all to imagine a pair of axes that look exactly like that. And I'd like you to imagine that we're going to have 142 points on these axes. And I'll tell you some things about these points. The mean x value is going to be 54.26. The mean y value is going to be 47.83. The standard deviation of x is going to be that number. The standard deviation of y is going to be that number. And if we do a linear regression line, we're going to get that line there. So I'd like you all to kind of imagine what these points would look like. And probably you're not expecting them to look like this. And this is, I guess the moral of the story here is, just because you've got the summary statistics, be a little bit careful about thinking, I know what this data looks like, because it could be one of the examples like this. And there's a few famous examples of data like this that people use to kind of give people this scare story. One of the most famous ones is called Anson's Quartet, which maybe we should be calling the Same Stats Quartet, which is these four data sets here, which have the same summary data, which I've written down the side here, but look very different, which kind of warn you like outliers are a real problem. Outliers are a real problem, because this really messes up the linear regression. And also the linear regression sometimes misses the point of curved data and loses some of kind of the randomness around the line. This isn't the only one of those. I showed you the dinosaur at the beginning. And there's another famous data set called the Datasaurus dozen. And this is a data set which all has the same summary statistics as the dinosaur I showed you. But there are 12 other data sets which all have the same summary statistics. And really make the point that just because you know those numbers at the beginning, you could have been imagining all of these things. If anyone's quickly counted, you'll notice it is a Datasaurus baker's dozen, because there are 12 plus the dinosaur. So I was thinking about these things, and I kind of got interested in how you generated these data sets, because if I gave you the dinosaur and said, draw me a data set with the same summary stats as this dinosaur, that's actually quite a difficult problem to solve. If you kind of do some random points, you're pretty unlikely to get the same summary statistics as the dinosaur. But there's a neat way they wrote up in the paper for the Datasaurus dozen that you can generate these data sets. What you can do is you can pick a starting data set, this is the one I decided to pick with, and then you can move all the points around a very small amount and check if the summary statistics have changed to 2 decimal places. If they have changed, you go back to the one you used to have. If they haven't changed, you keep the new one, and then you shuffle them again, and you keep going. And if we do something like this, this is happening live right now. This all has the same summary statistics to 2 decimal places, and these are currently moving randomly. And we can leave it on for ages, and we'll get something looking very, very different. And you kind of repeat the shuffle, and if you want, you can go back, you can start again, and you get them moving in a slightly different way. And you can do this to end up with a new data set which has the same statistics as the previous one. And once you've got this going, you can then pick kind of a target shape you'd like, and you can add an extra rule where if the new set of points you get is a bit closer to your target shape you'd like, you can keep it, and if it's not close to that, you again throw it away. And I did this and left it going for a long time. I picked this target shape here, an A, and eventually ended up with this data set, which has the same summary statistics as my star. And now that I've got one of them, and I left my computer running for a long time, I generated the whole alphabet. So we have this set here is the alphabet, and they all have the same summary statistics. I call this the Databet, which is a combination of data set and alphabet. And if you would like to go and play with it, it is on GitHub. That is in the Databet font. If you go on that GitHub page, you will find you've got JSON files which have kind of the points for all of them, so you can kind of play with them and plot them. I've also made a Python package, so if you go pip install Databet, you can import Databet and do databet.load letter, and that will load the JSON file up for you to nicely get into Python very easily. And finally, I've also made a font, so if you go to the GitHub page, you can install the font, and your next document for work is going to look fantastic. Thank you very much.